So today we will learn about, how you can run the blast on Ensemble, especially if you want to run multiple blast or mega blast. What I mean by mega blast is that you have a plethora of genes, and you can use those genes as a query, and then you want to determine the orthologs of those genes. One other thing that in this blast, I will also teach you, because this blast we are going to do for the non-coding genes, but you can also use it for coding genes with a little bit of variations. But this is for non-coding genes. Uh, so let's say first of all, we go for uh, uh, the blast here. We went to the Ensemble genome browser, and we went to the blast and start a new job. And you can put your sequences here of your gene of interest, of the genes whose orthologs you want to determine. Keep in mind that you can put maximum 30 gene sequences. So I am here genes. So let's say this is, let's say I want 30 gene sequences. Which, fine. Control C, and now we paste it over here. Paste it over here. So actually, what we want here, we have non-coding genes in the human, and we want to know the orthologs of these non-coding genes in the mouse. If it were coding genes, it would have been very simple. And I have already shown you in another video that how it's very simple for coding genes. You can simply use ensemble table, and you can very easily determine the orthologs of a gene. But here, because these are uh, non-coding genes, then it is there is no option in Ensemble to straight away find the orthologous non-coding genes of your query. So that's why we have to run this blast for this purpose. Okay. Now we have these are the human non-coding genes, and we in the search option we want to search these in the mouse, because we want to know the orthologous non-coding genes of human genes in the mouse. So we select the in the mice here. This one is here. We apply it here, and we do it blast. Fine. Now this is blast, and then we run it. It is running. So the blast is running, and it is almost done. You can see. So let's say for our so there were 30 genes in the query. So let's say we want to get to know the results of the first query. We opening in the new tab. We open in the new tab. Okay. So this is the genes, and now this is the result. This table actually shows you uh, the uh, potential orthologous genes, which are the ortholog to your gene, your query gene. Uh, Keep in mind that we usually select that gene from this result table. We consider that gene to be the orthologous to your gene of interest, which is at number one. So the which have biggest score, which is almost at number one. So there's a list of gene MYC, MYHC, MYH7B. These are different potential candidates, but we let's say we consider the gene which is at the top of the list, that is MYH6. We open in a new tab. It's always good to open your uh, 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 link in a new tab so that your main tab is uh, already there intact. It's important. I mean, sometimes it's not easy to always go back and forth to get to your page. So this is a gene in the mouse, and this is protein coding. That's fine because this was a unitary gene. Unitary pseudogenes are those genes which have their which are pseudogene in a species but have their functional ortholog in another species. So the in human, our Curie sequence was what we say was non-functional pseudogene, but in mouse it should be functional. So at least it shows here that it's functional, but we have to further see that whether this is really the orthologous of our unitary pseudogenes. So for that purpose, what we can see, we can go to the ortholog link over here, and we can look into, because it should not have any functional ortholog in human, because in human we already know that this gene is pseudogenized. So we go to ortholog, and we, let's say in primates, we find in human. Okay, so in human we have this one to one MYH6. What does it mean? That in human this gene is already functional. I mean, the gene, this gene have a functional ortholog in the human, which means that we cannot consider this gene MYH6 in the mouse. We cannot consider this gene the ortholog of a unitary gene. Fine. So we cannot select it. So that's why maybe we can do with this first with uh, this gene, which was a result of our blast. We at the moment we are not focusing on it because we couldn't find its ortholog. We will see later how we can somehow manage to find its ortholog. So uh, let's we uh, let's we go again with the gene two, job number two, which was your gene two, which you consider we should put as the Curie sequences. So this is now gene 2 again, as we did with the previous one. Let's we go with the uh, uh, top of the list gene. It's loading. Just wait for it. Okay, now again, uh, let's see. Okay, let's see its orthologs. Again, this is protein coding gene. Fine. This is this seems to be the, I mean, this is at least fulfilling one of the condition of the orthologs. for a unitary pseudogene, because unitary pseudogenes have an ortholog in another species which is functional, so that at least it looks functional. Now we go to the, let's see is ortholog. If it really in the human it like that or ortholog, let's see. Okay, fine. Human. Okay, fine. That's great. So also it doesn't have a functional ortholog in the human. So the second condition is also fulfilled. Now comes to the third. Now to further confirm it, let's we do a very important step that is known as the reverse blast. In reverse blast, what we will do actually, let's we uh, take this protein coding gene transcript ID, we click the cDNA here, and we reverse blast it with the human. What does reverse blast mean? That we, in the initial blast, we took the human cytogene, non-coding gene, and we blasted it against mouse. What we would in reverse blast, that's the result of that previous blast, which was the gene we found in the mouse. We blasted it against human again now. So that is the reverse blast. So we do it, change species, we do it in human, apply. This is blasted. Fine. And let's wait. Now, in the blast, reverse blast, the topmost hit, that is the first hit, should be our initial query sequence. Then it will be the really ortholog of our pseudogene which we were searching. So that is how reverse blast actually confirm us that this is really the ortholog we were finding. Yes. So it's again running. Actually, uh, so there are three conditions I must tell you which should be fulfilled uh, for a for a gene to be ortholog here for a non-coding gene. First of all, uh, the your you your gene of interest, which is a non-coding gene, the ortholog which you found after the first blast, that is the when you blasted the human uh, genes, human non-coding genes against the mouse, the ortholog you found, which was a potential candidate, it must be a coding gene. Fine, in the mouse. Number two, in the mouse ortholog, when you go in the mouse orthologous tables, which is provided by Ensembl, in that ortholog table, that mouse shouldn't have any ortholog in human, because Ensembl doesn't have an ortholog for non-coding genes. So if a mouse have a functional gene, and we know that in human that functional gene is cytogenized, Ensembl will not provide an ortholog. So second condition should also be fulfilled, that this gene which you found in the mouse shouldn't have an ortholog in human. Two. Number three, in the reverse blast, when you do the reverse blast, you should get the topmost hit, the same gene which was originally your query sequence when you did the blast in human. So that is the third condition. Fine. So here, he- so here you can see we have found the blast is completed. Let's see the results. Let's see the results. So let's we see in human with which gene we find. This is topmost gene hit. So it is let's see its ensemble sequence. It's 88340 is, ID. Let's see, was it the really gene which was we used initially in our first main blast? The job was job number two. It was 88340. Fine. Is 88340? Yes, this is 88340. Now it confirms, guys, that uh, this gene, uh, uh, which we used in the human, we consider in the human as the ortholog of our cytogene. That gene I show you here. Wait, actually it must have been here. Uh, this gene in the mouse. Uh, so this is, you know, now this is the harm you have to face when you really lose your major page, major tab. We somehow lost our major tab, so we have to go back and forth, back and forth to come to this page. So this is actually really our ortholog in the mouse. It's really the ortholog we wanted. We can say that this gene is the ortholog of human non-coding gene. So what we can do, we can copy it here. We go over to our panel, real list. We put it here in front of this. Was it this? No, that was not this one. So job. What was job number two? Let me see. Job number two was and 88340. Let's we see where is 88340. Find find 88340. Yes, it is here. Right? Yes, it is here. So let's we put our sequence here, ID here. This is in the mouse, so we can uh, this column we can title it like mouse. In this way, you can come across all the orthologs, fine, of your gene of interest, of your non-coding gene, I mean. Fine. So it may look a little difficult in the start, but when you will get practice, and you will see it more, you will see that it's not that difficult. So I think this is the only way at the moment that you can come across finding uh, ortholog of your non-coding gene. Reverse blast, you should know about blast, you should know about reverse blast, and you should know what is meant by ortholog, what's meant by pseudogene. Fine. And once your concepts are strong, you can run any app, you can run any software. Thank you very much.